We're going to talk about graphing some parabolas next, which seems weird when we're talking about graphing radical functions. Basically, what we're going to do is we are going to take this equation and solve it for y. And once we do that, we will be able to graph using our graphing calculator. So we want to solve for y. In order to solve for y, the first thing I need to do is get rid of this 1/2 that's out in front of y squared so that at least I have the y and the exponent isolated. In order to get rid of a fraction of 1/2, I need to multiply both sides by 2 so that the 2 on top and bottom will cancel, and I have y squared is equal to x times 2, or 2x. Now, if I want to solve for y and y is squared, I have to use a square root in order to do that. So I'm going to take the square root of both sides so that my square root and my squared cancel. However, when I take a square root or any even root in order to solve, remember that we have to have a plus and minus, so don't forget the plus and minus. This will give me y is equal to plus or minus square root of 2x. So we're going to plot each of those as separate graphs and look at them kind of overlaid. So y equal to plus or minus 2x. In my calculator, under the y equals button, y1 I'm going to put in square root of 2x, and in the y2 location I'm going to put in negative square root of 2x. And what we want to observe with this is we want to see where our vertex is for this graph, and we also want to observe if it's opening to the left or the right. Here we are over in our calculator, and this is my simulation of the calculator in class. You'll use the class calculators. If you're not in class, you can always put these equations into Desmos and see the same things. So I'm going to, under my y equals, I want to put in a y1 value that is the square root of 2x. So I am going to do my square root symbol, which is right above the x squared. So shift and the x squared gives me a square root, and I want to say 2 and x. And now under the y2, I want to do a negative 2x. So negative square root of 2x. So shift an x squared and put in a 2x. Now I want to look at a graph. You can see that our vertex is at 0, 0, and it opens to the right. Back here in our notes, just to do a super rough sketch, we saw that our graph looks something like this. It had a vertex at 0, 0, and it opened to the right. And that's what we were asked to do with this one. So even though it looks like a parabola, like I said, technically it is two separate square root functions that are making this sideways parabola. Why don't you try number 7 on your own and then come back here to see how you did. Okay, here we go. Problem number 7. I noticed that the first thing I want to do is get rid of a negative 1/5. Well, I get rid of a negative by multiplying by a negative, and I get rid of a 1/5 by multiplying by a 5. So overall, I'm going to multiply each side by negative 5. That will leave me with y squared on the left and a negative 5 times x on the right, and I'm ready to take square roots to get rid of the y squared. Don't forget your plus and minus because this is an even root. So I will end up with y equal to plus or minus square root of negative 5x. Now, negative 5 under the radical is okay because it's accompanied by an x. And if x is also negative, overall this thing under the radical, the radicand, will be positive. And so in our calculator, we're going to put in square root of negative 5x and a negative square root of negative 5x. Once you put this in your calculator, you should see that the vertex is still at 0, 0, and that we open to the left. Notice that we don't have any graph over here in the positive x values. That's because it's undefined over here. We have to have a negative for the x so that overall our square root's radicand is positive. The last thing that we're going to do today is graph a circle. In order to solve, we're going to do that by again solving for y and then putting our equations into the y equals of the calculator. So if I want to solve for y, I need to move x squared over to the other side. So I'm going to subtract x squared from both sides. This will cancel, leaving me with y squared is equal to 16 minus x squared. In order to get rid of y squared, I again need to take a square root so that the square root and the squared will cancel. And if I do that to one side, I need to do it to the other, remembering that I need plus and minus because we have an even root. Breaking this into two pieces, I will put into my calculator that y is equal to the square root of 16 minus x squared, and then y is equal to negative square root of 16 minus x squared. Let's go to the calculator and see what that's going to look like. This time we're going to want to identify the radius of our circle and the intercepts, and let's actually do a graph of it. Back over here in the calculator, or in Desmos, if you're at home and don't have access to a calculator, you're going to go to the y equals again, and under y1 put in one of your equations. So we will put in the positive, so root, which is the square root, remember it's shift, and the x squared, and then you can put that in as 16 minus x squared. Under y2, I'm going to put in negative, and then that same root. Shift x squared to get my square root, and then 16 minus x squared. Let's look at a graph. All right, so right now it looks kind of like an ellipse, but that's just because my x and my y scales are not correct. On your calculator, you should see those as the same in each direction, but let's just count tick marks here. If I start at the center, which is at 0, in order to get out to the outside here, I am at 4. My furthest to the left is also an x value of 4, and in the y direction, positive and negative 4 as well. Again, my x is just a little stretched. Yours will hopefully look a little better on your calculator. Let's go ahead and draw a graph that looks a little better than the one that we just saw on the calculator. So I'm going to put points at positive and negative 4 in the x and the y direction and do my best to draw a circle. Now my little program here is going to cheat for me and probably make a prettier circle than I can by myself. Look at that. Okay, so we have a circle that has intercepts at plus and minus 4 in the x direction and the y direction. So my radius, my r value here, radius is equal to 4. My x-intercepts are at plus and minus 4, y-intercepts at plus and minus 4.